Okay, people, it's time to talk lube. And before any of you start cracking schoolboy jokes, we're talking specifically about Lube Wear. We're about to be joined on the show by Adam Cutler of Oil Analysis Laboratories. Good morning, Adam. Thanks for
Good
joining
morning.
us.
Thanks for having me on.
No problem at all. Now, oil analysis is not new. As far as I know, the demolition construction industry have been using it for decades to spot early signs of internal wear and to preempt potential equipment failures. So, how does lube wear differ from what we already know about oil analysis?
That's right. In fact, it started back as just after World War II. Oil analysis actually started, so it's been going on for quite a while now. And really, the technology hasn't particularly changed in all those decades since. There's been slight improvements, but the main concept is that you heat the sample up to about 10,000 degrees Celsius. So that's about twice the surface temperature of the sun. So pretty toasty. And you measure the wavelengths of light emitted, which tell you which wear elements are there. So how much copper, lead, or tin. Now, the problem is that works perfectly for small, normal wear particles. But in a lot of the machinery, particularly construction machinery, there may be some abnormal wear. In fact, you may have, particularly some of the people watching this show, may have gone and taken an oil sample before, and when they've taken an oil sample, seen that they can actually see the metal particles. Now, normal oil analysis can't see particles that you can see because it can only cope with the small particles that are in the system. And the reason that is it vaporizes the sample. So if we take, for example, we were trying to test chickens and we put a chicken into the oven and we put it at a very high temperature for a few seconds, we'd cook all the outside of the chicken, but the inside would not be cooked. And we only can measure the cooked stuff. So we're only measuring the outside of the particle. And so large wear are large particles and we're not measuring them. And that's a key flaw in that we don't detect all the wear in a sample. So it may be in the bottle, but the lab can't test it with ordinary oil analysis. And that's why we invented Lube Wear, which breaks apart those large particles into small particles. So a bit like with a chicken, if you want to get it to cook quicker, you would dice it. And so you get a smaller bits of chicken, give more surface area, and so it cooks quicker, and so you can measure it quicker.
I like the fact that you've obviously identified my level of intelligence by translating science into cooking chicken. Brilliant. So, you mentioned the fact that there are some larger particles. Do those larger particles indicate a different type of wear?
Yes, absolutely. So normally when we're talking about wear particles, everything wears. So all machinery will have some wear being generated all the time, and that's just normal part of the process. And those normal wear particles are less than 15 microns. Now, just to give you an idea of size there, a grain of sand is about 70 microns, and the width of a human hair is about 80 microns, 80. So we're only talking about 15 microns, so very, very tiny. And that's normal wear. Anything above that is considered abnormal wear. And I mean, sometimes you can see stuff up to millimeters or centimeters in size. Obviously, that's very abnormal wear particles. And so when you get to the larger particles, that means it's abnormal. And that's what we're able to detect that ordinary oil analysis doesn't detect.
So, I mean, in effect, as you said, oil analysis has been around for a very long time indeed. Are we to assume that what we're seeing as oil analysis today is actually wrong?
Well, yes. It's actually quite surprising that most of your oil analysis report you see is all the wear elements. Obviously, there's other tests too, but most of it's the wear elements. And if you've got an abnormal wear process, most of that material won't be detected. So yeah, the reports you're getting currently, if you're not getting lube wear analysis, is most likely missing that wear and potentially missing failures.
Now, we've got our friend and colleague Peter Haddockers in the chat there. Love the chicken analogy, as did I. Fluid sampling is so important to understand the health of the machine on the inside. Preventative maintenance and trending data are essential to stop major component failures. Trending data, that's something that you mentioned to me off air. Yeah. Take me through what trending data is and how your system differs to perhaps what is going on at the moment.
Okay, so with ordinary oil analysis, because they're not detecting those large particles, they can't determine the absolute amount of wear present. So they tend to work on what's called a trend. Now, that's basically just looking what values are in the past. So if I give you an example of anything, if we say we've got a value of 100, 103, 105, 106, 225, the oddball number there is a 225. I've not told you what test it is or what machine type it is, but just it looks different to what the previous results were. And that's basically what trending is. And that's essentially what a diagnostician normally does when they're looking at the oil analysis data. They're just looking for a kind of like a step change, so to speak, in the wear data. Now, you normally require 4 samples to get a trend. Now, on a typical sort of maintenance schedule, that could be anywhere, and assuming it's got a decent utilization, that could be anywhere up to a year before you can actually make a decision on a little bit of wear you've started seeing, how significant it is, because you need to get 4 samples in a trend. Now, with Lube Wear, because we can detect all the wear particles and we compare it to the ordinary type of analysis that you already be getting with your standard oil analysis, we can actually, on a first-time sample, determine if there's actually a problem or not. So it means that we don't have to wait for the trend. It means we can very, very, very quickly identify a problem much earlier than any other analysis can offer.
Now, we've had a comment there from our friend Ken Hatcher. I think it works better on big plant with big oil compartments. Is there any truth in that, or does this apply literally across the spectrum of plant and equipment?
Well, it works on everything really, in terms of anything that's oil lubricated. So, I think what he's arguing there is, obviously, if you've got very expensive machinery, then the returns on investment are much, much better because they're so expensive and they're so critical. But even smaller machinery, you still get the benefit from actually taking an oil sample, because it is always cheaper to repair before the failure. So in a vast majority of cases, that will be the case, because you've got a machine that you can identify it very early and spot it early. So I wouldn't say it's a large compartment and large machines that it's only for. Yes, they will be the key ones that do it, because they'll get the biggest bang for their buck, because it's the most expensive equipment. But even we even do small passenger cars and do oil analysis on it and show customers problems and identify them early. And we do quite a few car OEMs. Again, compared to construction equipment, they'll be quite cheap machinery.
Just going back, I mean, on that basis, I guess, any machine can be mission critical on a construction project. It might even be a mini excavator, but if that mini excavator stops, then the site dumper isn't working. Maybe the footings on a house building site aren't being dug. So I guess it applies right across the board. Given your trend analysis and that kind of thing, does your system require more frequent testing than a regular oil analysis?
You don't need more frequent testing. We still recommend going with the standard sort of sampling intervals that you're currently doing. But if you wanted to reduce those sample intervals to kind of save on the amount of samples or kind of extend services, we can help our customers manage that as well. So we have got some customers, for example, who've managed to extend their drain intervals and change their service regimes to more convenient to them based on the oil sampling.
How does that tally with things like warranties? Because obviously, OEMs are very protective of their warranty rules and regulations. If you're extending service intervals, is there not a danger that you'll be endangering your warranty?
Okay, so lots of OEMs will have some sort of terms and conditions that you regarding oil sampling and the warranty. Most of them will have a comment in there, words to the effect that you need to be. It's a condition-based assessment. So you can do extended drain intervals in those cases. You need to look at your particular warranty terms, but I know a few OEMs, they have some stipulations. It has to be on the OEM approved oil to do this, and it has to be combined with, say, an oil sampling program. But there's nothing per se to say a warranty will prevent you from doing it. You just need to check, is there any sort of clause that specifically says it? But most warranty terms will allow you to do extended drain intervals, but you need to back it up with potentially either using the OEM oil or using an oil sampling regime or something along those lines to back up your decision to extend it.
Now, you've already answered that question from Ken Hatcher there. You can extend the oil change intervals, big cost on big plant, absolutely. Peter Haddock has been back with another question. How does the customer get the data? And also, if a red alert is spotted, what happens? Now, just before we came on air, you actually told me specifically about one such red alert.
Yeah.
Entertain us with that red alert story.
Well, we were just talking just off air about an example of a customer that we had that we'd spotted an alert that they'd never had before. So in this example, this was a customer. They don't mind me saying it because they often use it, this case study themselves. The customer is Banks Mining, and we had actually started doing their oil sampling. We'd only been started about a week or two doing their sampling, and had previously been using other labs, used a couple of other labs, and no one had ever identified an issue on this system. And on the first sample, we said, look, there's a real problem. We actually called them up, telephoned them up, actually left them a voicemail to say there's an issue. And unfortunately, the person that was our point of contact wasn't actually in on the Friday. We left the voicemail to say this is going to fail if you don't do something about it. On the Monday, he came in and picked up his voicemails. And on that same day, it actually failed. So from then, I never had a call not answered from that period of time, because they realized how critical a phone call from the lab is. But it just shows that they've been having regular sampling. They'd never picked anything up on that particular sample point, and we on our first sample picked up the problem, and potentially they could have actually saved they could actually save that machine if they just answered the call in that case. And we have actually probably saved about 20 or 30 sample points for them on that machine over the next few months, just show with a similar sorts of issues. And we've actually managed to stop a lot of failures for them. And we've got countless cases, not just in the sort of construction and mining sector, but in power sectors, in lots of different areas. It's the same pattern all along, factories. And we can, on that first sample, pick up problems that potentially they would never have had picked up with an ordinary analysis.
I realise that pricing these sort of things is a bit like how long is a piece of string, but given what we were talking about, extending oil change intervals, extending drainage intervals as well, but also that prevention of failure, how does the cost of your system stack up against those potential benefits? I mean, obviously, when you're talking about a mining machine, even if it's cost them £5,000 to do an oil test, and the machine's down and it's cost them £50,000, they've had a benefit there, haven't they?
Yeah.
How do you balance those two?
Okay, so normally you would, and these studies have been conducted not just by ourselves, but by pretty much every OEM who's conducted some sort of study on this over the period of time, over decades. And you generally get, for every pound you spend, approximately £10 back in return on investment. And that's with ordinary oil analysis. You'll get that sort of return on investment, and it's factored in that won't detect all the problems. So you can only get more with detecting those problems earlier and identifying those issues, because we're not missing the failures that ordinary analysis is missing. So even in a conservative estimate, you're getting a 10-fold return on investment for your typical construction machinery.
We've had another question there. Ken Hatcher's back again. Would it be worth me testing the oil in my Toyota? I'm going to say Toyota, even though he's put Toyota hybrid car. Would it be worthwhile?
Absolutely, and we do as I said, we do car and vehicle samples. We're actually being featured in a publication coming out soon about testing hybrid vehicles and some of the problems that I won't spoil the person who's releasing the article's thunder, but it's going to highlight why hybrid vehicles really benefit from doing oil analysis, just because of if you think about it, the engine's not always on, and the kind of repeated stop-starts, the kind of issues you get from that, and why that's particularly important to do oil analysis in those situations. But yeah, it's used for cars, and we do a lot of cars, both from like a servicing side, from end consumers using it. We even went on a television program called Car SOS on National Geographic Channel, covering and doing oil analysis on that as well. So yeah, car analysis is a big thing as well.
You just mentioned a couple of things there that really triggered with me. One of which is this stopping and starting. Obviously, with the hiking the cost of fuel, there is that desire to shut machines off to preserve fuel, and then to start them again when the machine is required. my first question, I guess, is does that impact upon wear particles and potential wear and tear of the engine and the engine system? And my second question, I guess, is there's obviously been a big upsurge in the uptake of things like biodegradable lubricants. What does that impact upon what it is that you do? Do you see a different level of wear with biodegradables?
Absolutely. So, so a couple of things there. So, in terms of the stop-start sort of cycles, generally that's not. It helps fuel economy, but generally stopping and starting are not good for the engine. It works best, and when they always do like the fuel economy ratings, and that they're always based on like a consistent speed, a consistent engine turnover, etc. So the stopping and starting is where the most wear takes place, because that's the when the load's suddenly transferred to everything. So the stop start is where you get most of your wear particles in those sorts of conditions. You also don't get the oil really ever fully up to operating temperatures, so you get things like condensation, and it can also just you running at the wrong temperature, so you can get a bit more drag and things like that. One thing just out of interest, obviously with the cost of fuel at the moment, quite a few studies have been shown that doing both oil and fuel analysis as a combination, you can actually save up to 12% fuel economy. You can actually increase your fuel economy by 12%, basically because like contaminated oil and fuel can actually increase your fuel consumption by up to about 12%. Then you also asked about biodiesels and biofuels, and generally, the more sort of like greener or biodegradable or environmentally friendly products and systems you have put onto machinery, that's generally at the detriment of the components themselves. So for example, you have a lot of like, for example, if you say exhaust gas recirculation, all that rubbish doesn't go out the exhaust now, which is good for the environment, but all that ends up in the oil. And then, for example, obviously said biodiesels and that. So biodiesels will have like different ignition temperatures, and you'll tend to find that those fuels will cause other issues, potentially with the oil when you get dilution with biodiesels. So in answer to your question, the more environmentally friendly you get, you have to be more conscious of looking at the condition of the machinery, because there's less wriggle room as you get with the less environmentally friendly products and good old hydrocarbon type stuff.
You win in one hand and you lose with the other. I've got a couple of comments here. Nick Drew from the Digger Man blog. My sentiments entirely. I've turned off the stop-start feature on my car. If I can figure out how to do that, I might go and do that myself, actually. And a comment from Ken, which I'm sure you'll enjoy. This guy knows his stuff, and I'm fairly sure he means you and not me. Now, Kenny's actually based down in Wales, and I think you're in Wales as well, aren't you?
Yes, yes, we're in Colwyn Bay, which is just off on the North Wales coast. So we're about an hour from Chester Drive.
Awesome stuff. Now, the final question for now, I guess, is where can viewers find out more? I'm not expecting them to drive down to Colwyn Bay and knock on your front door. Is there a website or somewhere that you need them to go to find out more?
If you go to oilanalysislab.com, that's oilanalysislab.com.
Fantastic. It's been really enlightening, Adam. I really do appreciate you sharing your expertise today. It turns out I thought I knew very little about oil analysis. It turns out I know even less than I thought I did. But really appreciate your insight today. And as I say, when this show's over and I upload the recorded version, we'll put a direct link into your website as well. But until then, thanks very much indeed for joining us.
Thank you.
All the best.